This time we'll put the game world together by getting the city map drawn on the screen just as it appears in the original game. We'll start by converting our map files from the original binary format to something closer to UTF. Then we'll draw the map to the screen starting with a slow process using only main memory. We'll close by moving the map to video RAM to boost drawing performance. Before we work on the map, I want to go into GameMaker and fix an issue from the last programming video where we built the briefing sequence. I put off the destructor event because we hadn't created the child objects yet. Since I'll be skipping through the briefing in this video several times, I want to get the destructor working. I'll just make sure that when the briefing object is destroyed, all the children are destroyed too. That's it for the fix. Let's take a quick look at the design document. So to get the map on the screen, we need to build this path. Our first task is to alter the original map files so that GameMaker can read them in as text. Again, this is because I want to use the HTML5 module, which doesn't support binary reading from web server data files. We'll do this work in C, so let's go to the data file directory and make sure we have everything. All the files are here, so let's grab a makefile and edit it with the new file name. I'll start a new C source file. It's easier to understand this process if we look at the original map file in a hex editor. So the issue is that all these data lie in the control character space, and we lose some of the values during a text read. So we want to shift all the byte values up by 32. We have plenty of room to do this as UTF treats all values below 7F as regular values. So just read in the byte value and write it to a new file with a higher value. And actually, I'm going to add a new line after each value just to simplify reading in GameMaker. It's less work to handle it in C than it is to script parsing a long single string in GameMaker. So in main, we'll make the output file name by changing it based on the input file name. Then we'll open the files, process the byte stream, and close the files. Get the name, cut the extension, null term it, so I can concatenate a new extension. Open files. So we'll just stream through the input file, writing out each byte value 32 higher. I'll add a line feed and carriage return. Close, and that should do it. Wow, how'd I mess this up? Oh, I forgot to say which fput we're using. The choice is either fput C or fput S. We want C. Okay, that worked. File is now 3 times the size due to all the new lines. Let's drag the new first episode map into GameMaker. So the first thing we'll do is edit the room size. Remember, our city maps are 6400 by 6400 pixels. We'll enlarge the room, but our view will keep the screen size the same. Then we'll create a reference to the master game object. We need to initialize some map variables. Let's start with a trigger that will instruct the object to draw a new surface in video RAM. We'll use this later. Then we'll define our map sizes. We'll set a draw mode so I can quickly demonstrate the difference between both approaches later. So for the data structures, we'll need the map data grid, which organizes sprite references, then the collision grid. I'll make a handle for the surface, but I'll leave it at 0 because I'll only set it if we're using the correct draw mode. No point in wasting video RAM if we're not using it. Now let's load the map data. So I was going to write an if ladder here telling the object to look at the current mission to decide which map file to open, but since I only brought in one file, I'm just going to go right to that one. Later we'll have to go back and add the others. Now let's read everything in column major, so we'll put the X value in the outer loop. We'll need to read in each character and then put it in the grid after lowering that value back to the original. Now I want to set the collision grid based on the values we're reading. Remember, each value is actually a reference to the background sprite. Most of them are walls. So I'll default the collision map to 1, which means to say there is a collision here. But to find out which ones are not collisions, we'll have to check the BLK sprite file, which I forgot to bring into GameMaker. Let's go get it. I'll make a group first. Here's the file. It has 80 sprites in there, so I'll rename the file as such and drag it in. Let's focus on the sprites with roads. I see a group of 3 here and here. Let me find those values in hex. .49 is 31 hex, and 59 is 3B. So we want 3 consecutive values starting at those points to let's set the collision map to 0, which means no collision. We'll read the line after each byte, then close the file. That should be good for the create event. I'll make the usual destructor. So for the draw, I'll start using the basic idea of drawing every sprite in the world every frame. This is pulling the sprite references from RAM and drawing all 40,000 sprites each frame. This is a start, but it's usually never the way to go. We're just trying to get it to work first. Just a simple double-nested loop where we'll look up the value from the grid and use it as the frame variable for the draw sprite statement. That's it. But before we test, I want to make the camera object. We'll register the keyboard and reference the game data. I'm not sure we'll actually use that reference. So the camera is just going to be an abstract object that's invisible in the room, but the view is always focused on it. I'll always keep the camera locked to some other object, like the player's ship, but for now I'll just lock it to itself. I'll start it in the middle of the room. I want the game to always focus on the camera. Keep the view at 320 by 200. And I don't want any drift, so I'll set the border to be half the room dimensions. Destroy deregisters the keyboard. Now in the step event, I want to process the keyboard. Since we're testing, I want the keys to move the camera around. Let me check the keyboard values I want. Okay, hold left, right, up and down. I'll just make them directly affect the X and Y values. Each step, I want the camera to make sure it always stays locked to whatever it's assigned to. Now I want to set up a room start event to lock the camera to the player, but since there is no player ship yet, I'll just lock it to itself. This is redundant for now, but it'll be useful next time. Ironically, there's no draw event for the camera, unless we want to debug something. Now I want to create the room init scripts and launch both objects. Put the init script in the room. Now we test. I'll run it in debug mode so we can see the frames per second and the memory usage. Looks like we use about 90 megs of memory on startup. Oops, looks like there's a typo. Something in the load map event. I'm trying to open the file again instead of reading from it. Let's go fix that. Let's try that again. Okay, we're in the room and I can move around with the arrow keys. Looks like we're pulling only 40 FPS or so. Memory usage is at 90 megs, which is where it was when the game started. Let's see how this changes when we move the drawing to video RAM by using a surface. I'll change that draw mode. So before we went right from the map data to the screen. Now we're going to go this way. So that new surface trigger will come into play here. If the new surface doesn't exist, we'll create it. If we're creating it, we'll basically use the same draw routine as before, except we're drawing it to video RAM and not the screen directly. Make sure we reset the target and draw the surface to the screen. This draw block will only run when the surface hasn't been created yet. On subsequent draws, we'll only be executing this draw statement. Game starts at 90 megs or so, as usual. There we go. Now we're getting frame rates of around 1,000, and our memory usage has ballooned up to 250. This is what we expected last time when we calculated that a 6400 by 6400 4-byte surface would cost us 160 megs of video RAM. So this plan worked out. I'm going to leave the drawing method here for now, but we could easily refactor the memory usage down if we wanted to use a smaller surface that gets redrawn as the ship moves through the world. Next time we'll be thinking about the ships and how they interact with the world that we just built.